Let's talk about rounding. So first, some vocabulary, approximate versus an exact value. So approximate is a value that is rounded off. Some part of the value has been lost. An exact value is not rounded off. It's an integer, a fraction, or some more complicated expression involving irrational values like pi, square roots, logarithms, etc. In general, if there's a decimal point involved, it's probably not an exact value. Some examples, just a reminder, it doesn't matter how many digits you keep, it's still an approximation if it's not a rational number, if it's not a terminating decimal. So we have like 1/4, 0.25 is a decimal that's an exact value of 1/4 because it's a terminating decimal. But if you're not being asked for the decimal, if you're not given rounding instructions, generally stick with the fraction form. 0.3 would be an approximation, a rounding off of that 0.25. 1/3, the exact decimal form would be 0.3 with the bar over it, meaning repeated. So that 3 keeps being written forever. So any number of 3s you write, you eventually stop. Now it's been rounded off and it's not an exact value anymore. Whether you write 1, 2, 3, 20, 100, 1,000, a billion of those 3s, it's still approximate. For pi, 3 would be a very imprecise approximation. 3.14 is commonly used. 3.146 for those that want to be a little bit more precise. You have on your calculator a pi button that's going to give a much more precise, essentially considered exact, but it's still probably stored as actually rounded off with many, many digits, more than what you can see. But again, no matter how many digits you write, it's still an approximation. Likewise, square root of 2, that's the only way to write that as an exact value. As soon as there's a decimal involved, it's an approximation, whether that's any number of digits included. So when should you use approximations rounded off? Not very often in this course. Generally, you're giving those exact values. There are a few contexts when it's real world problems, then you might need the decimal, the approximation, because that is going to make more sense as a meaningful answer. If you're supposed to give an approximation, you'll be given rounding instructions. So if you don't see rounding instructions, you shouldn't be giving an approximation. You should be giving an exact value. When you are giving those rounding instructions, though, the important thing is that you know how to actually follow this instruction so that you're rounding correctly, so that you don't get counted wrong because you didn't follow those rounding instructions. One thing to note is you don't apply those rounding instructions, the rounding rules, until your final answer. Any intermediate answers that are going into other calculations shouldn't be rounded. So use your previous calculator result in the next calculation directly. There's ways to tell your calculator to do that, figure that out, or figure out how to do it all as one calculation. So rounding rules, typically you'll be given a number of decimal places, which would be how many digits after the decimal point, or it might be given the place value name to round to, so 10th, 100th, etc. So the last digit kept either stays the same or goes up depending if the next digit after it, the first digit removed, if that's at least 5, then you go up. If it's less than 5, you stay down, because we're looking for the nearest rounded value. If we look at this number line below, if we want to find the of these decimal numbers, the one whose nearest whole number is 0, well, we get in the middle here, we have the ones closer to 0, and then the ones 0.6, 0.7, etc., those are actually closer to 1. And then on the other side, if we cut off halfway, we have these that are closer to 1, 1.1, 1.2, 1.3, 1.4, and then they're closer to 2. So those would round to 2. Now what we have is that middle, the 0.5, is that closer to 0, closer to 1? Technically, it's exactly halfway in between, but we have to decide that it's going to go somewhere. And so the rule is that if it's up to the 0.5, that's the cutoff where it starts rounding up. So any of these decimals then would round to 1, up to but not including 1.5. Once you get to 1.5, that would start rounding to 2, and so on. So just to review the place value, 1 digit after the decimal point would be 10th, 2 digits after the decimal point, 100th, or cent if it's money. 3 digits after the decimal point would be the nearest 1,000th. So those 3 words, you need to know what those mean. Bigger than that, it'll just say the number of digits rather than the name. All right, so practice rounding, and I'll leave it up to you. We have these calculations to make sure that you can put those calculations into your calculator and get this result. But we have these calculator outputs here, and they're being rounded then. So this first one rounded to the nearest 10th. So we're keeping just that first digit after the decimal point, but I have to look at the next digit. And because it's bigger than 5, this result is actually closer to 0.9 rather than 0.8. We round up. 251, 0.6645, etc. round to the nearest cent. A caution here, you don't want to round multiple times. So if I take this and go to the 3 digits, that would go 0.665. And then if I round to the nearest cent, it would go 0.67. That's not how you should do it, though. If I look at the whole thing, the 0.6645, that's still actually closer to the 0.66 than to the 0.67. So don't round and then round again. Always go back to the original unrounded value to do your rounding. So 251.66. 2 digits for the cents. And then 0.742857, etc. to 4 decimal places. So we're keeping the first 4, and then we look at that next digit after, and it's a 5. So we're actually closer to the 9 than the 8 on that last digit. So this would be 0.7429. So that's rounding.